Projected 50% increase in international biosecurity regulations, implications for healthcare, pharmaceuticals, and agriculture sectors by mid-2025. Date: January 26, 2025. Event summary. The anticipated 50% increase in international biosecurity regulations by mid-2025 is poised to substantially influence the healthcare, pharmaceuticals, and agriculture sectors, particularly regarding antimicrobial use and resistance AMR. This report synthesizes critical findings from various sources highlighting the implications of these regulatory changes. Key insights. 1. Antimicrobial use and regulation. Recent data from the European Environment Agency (EA) indicates a significant reduction in veterinary antimicrobial use in Europe, with a 28% decline from 2018 to 2022. This trend aligns with the EU's goal of reducing antimicrobial use in food-producing animals by 50% by 2030, driven by improved biosecurity practices, vaccination programs, and enhanced diagnostic measures. The WHO has classified AMR as a major global health threat, prompting stricter regulations and monitoring in Europe and beyond. Veterinary antimicrobial use decline. The data reflects a movement towards sustainable agricultural practices, with the EA emphasizing the need for continual action to achieve the 2030 target. AMR risks. The use of antimicrobials in livestock is a significant contributor to AMR, which poses threats to both animal and human health. Efforts to curb this trend through regulation and monitoring are being prioritized. 2. Environmental impact. Antimicrobial residues can contaminate the environment, as up to 90% of administered antimicrobials may be excreted, leading to pollution of soil and water systems. This environmental contamination can exacerbate AMR by creating selective pressure on microbial communities. Need for monitoring. Enhanced monitoring and data collection are crucial to evaluate the environmental impact of these residues and to inform regulatory frameworks. 3. Global trends and implications. As food consumption rises globally, especially for animal products, pressure on farmers to use antimicrobials may increase, contradicting the regulatory efforts in regions like Europe. The OECD and FAO predict an overall rise in antimicrobial use in food-producing animals globally. Interconnected food systems. The global nature of food production means that practices in one region can influence AMR trends elsewhere, necessitating a collaborative international approach to regulation and monitoring. Comparative analysis of sources. While all sources acknowledge the escalating importance of biosecurity concerning AMR, they differ in focus. Regulatory frameworks. Some sources emphasize the EU's successful regulatory measures, while others highlight the need for global collaboration. Historical context versus future projections. Differences in timelines are noted, with some sources detailing past successes, e.g. Denmark's initiatives, and others focusing on future regulatory necessities. Timeline of significant events. 1950s, 2006, initial veterinary use of antimicrobials for therapy and growth promotion, gradual rise in regulatory scrutiny. 2018 to 2022, EU 27 experiences a 28% reduction in antimicrobial sales due to regulatory measures and improved agricultural practices. 2023 to 2025, projected 50% increase in international biosecurity regulations coincides with ongoing efforts to combat AMR through enhanced monitoring and policy adaptations. Conclusion. The projected increase in international biosecurity regulations will necessitate substantial changes in antimicrobial usage across healthcare, pharmaceuticals, and agriculture. A coordinated multi-sectoral approach is essential to mitigate risks associated with AMR and environmental contamination. Collaborative efforts at both national and international levels, supported by robust data and monitoring practices, will be crucial for the success of these initiatives. References. 1. European Environment Agency (EA). 2024 Veterinary Antimicrobials in Europe's Environment, a One Health Perspective. Retrieved from EA Publications www.ea.europa.eu/publications/veterinary antimicrobials in Europe's environment. 2. World Health Organization WHO. 2023 Antimicrobial Resistance, a Global Health Threat. 3. Organization for Economic Cooperation and Development OECD. 2023 Antimicrobial Use in Food-Producing Animals, Trends and Projections. 4. Food and Agriculture Organization FAO. 2022 The State of World Fisheries and Aquaculture 2022. 5. European Centre for Disease Prevention and Control ECDC. 2024 Antimicrobial Resistance in the EU/EA Annual Epidemiological Report. This report serves as a comprehensive overview of the implications of increased biosecurity regulations for key sectors, illustrating the need for integrated action to address the challenges posed by antimicrobial resistance and environmental contamination. The projected 50% increase in international biosecurity regulations by mid-2025 brings with it a host of implications that may seem straightforward at first glance but contain counterintuitive aspects that merit further exploration. This increase primarily targets the healthcare, pharmaceuticals, and agriculture sectors, particularly relating to antimicrobial use and resistance AMR. 1. Antimicrobial use and regulation. One of the most surprising findings is the significant decline in veterinary antimicrobial use in Europe, which has decreased by 28% from 2018 to 2022, with aims for a further 50% reduction by 2030. This decline suggests that effective regulatory measures can lead to substantial improvements in antimicrobial stewardship. However, counterintuitively, even with these reductions, global trends indicate an anticipated increase in antimicrobial use in food-producing animals, particularly in regions like Asia, Africa, and the Americas. This points to a paradox where stringent regulations in one region may lead to increased pressures in another, exacerbating global AMR challenges. 2. Environmental impact. The environmental consequences of antimicrobial use are significant. Up to 90% of administered antimicrobials can be excreted and enter soil and water systems, creating selective pressure on microbial communities that can lead to increased AMR. This raises a counterintuitive issue. While reducing antimicrobial usage in agriculture is essential for public health, the residual effects of previously used antimicrobials in the environment may continue to pose a risk. Hence, merely regulating current use does not eliminate the historical impacts on AMR. 3. Global trends and implications. As global food consumption, particularly of animal products, rises, so does the pressure on farmers to use antimicrobials, potentially leading to an increase in AMR despite regulatory efforts in developed regions. This is particularly counterintuitive when considering that reductions in antimicrobial use in regions like Europe could inadvertently lead to higher usage in other parts of the world, driven by demand from those regions. This interconnectedness highlights a global regulatory gap. Effective local regulations may not translate into global improvements without coordinated international efforts. 4. Differences between sources. While sources agree on the rising importance of biosecurity and its implications for AMR, they diverge on focus and interpretation. For instance, one source may emphasize the EU's success in reducing antimicrobial use, while another stresses the global implications and the need for collaborative international regulation. This discrepancy illustrates a counterintuitive reality. Localized successes in regulation do not necessarily translate into global improvements. Instead, they may highlight the complex interplay between local practices and global market demands. 5. Timeline of events. The historical perspective of antimicrobial use illustrates another counterintuitive aspect. the long history of antimicrobial use in agriculture has created a situation where regulatory successes must contend with decades of ingrained practices and consumer habits. The timeline indicates that significant reductions have occurred, but the timeline also reveals the potential for increased pressure on animal agriculture as global consumption rates rise, suggesting that past successes may lead to complacency in addressing future challenges. 6. Health implications. The most direct health risks associated with antimicrobial use relate to the emergence and spread of AMR. Although AMR rates among certain bacteria in Europe remain low, the potential for zoonotic diseases and AMR to spread from agricultural settings to humans remains high. This situation is counterintuitive. While improved practices may reduce AMR in one region, the interconnected nature of global food systems means that risks may be imported from regions with looser regulations. Therefore, localized improvements may not equate to improved public health globally. 7. One Health approach. The One Health approach emphasizes the interconnectedness of human, animal, and environmental health, advocating for a transdisciplinary approach. However, while this perspective is gaining traction, it also reveals a counterintuitive dilemma. While the approach recognizes the need for comprehensive strategies, the practical application remains fragmented. Efforts to reduce antimicrobial use in animals are often pursued without adequate consideration of the environmental reservoirs of AMR, leading to a gap in effective management strategies. 8. Mitigation strategies. Strategies to reduce antimicrobial use in food-producing animals include enhancing biosecurity measures, improving animal welfare, and promoting alternative farming practices. However, the effectiveness of these strategies can be counterintuitive. For instance, increasing animal welfare may lead to higher costs and consequently increased pressure on farmers to use antimicrobials to maintain productivity. Moreover, while promoting organic farming can reduce antimicrobial use, it may also lead to increased reliance on alternative treatments that are not always proven to be effective, potentially complicating the AMR landscape. Conclusion. In summary, the projected 50% increase in international biosecurity regulations will drive significant changes across healthcare, pharmaceuticals, and agriculture sectors. However, the counterintuitive nature of these changes underscores the complexities and interconnectedness of global systems. Regulatory successes in one area may inadvertently foster challenges in another, and localized approaches may not adequately address the broader implications of AMR and environmental health. Thus, a coordinated global approach is essential to effectively mitigate the risks associated with antimicrobial use and resistance. The projected 50% increase in international biosecurity regulations by mid-2025 is a critical development that warrants close examination, especially in the context of antimicrobial use and resistance AMR as it relates to the healthcare, pharmaceutical, and agricultural sectors. While many may focus on the immediate implications of these regulations, several underlying aspects often overlooked are significantly impactful. Overlooked content and its significance. 1. Interconnectedness of global food systems. The interconnected nature of global food systems means that practices in one region can influence AMR trends worldwide. While the European Union (EU) has made strides to reduce antimicrobial use, the increasing global demand for animal products may push farmers in other regions to intensify production practices reliant on antimicrobials. This dynamic can exacerbate the AMR crisis globally, highlighting the need for coordinated international regulatory frameworks. The significance lies in the fact that AMR is not just a local issue but a global health threat that requires international cooperation and shared best practices. 2. Environmental contamination. The report emphasizes that up to 90% of administered antimicrobials can be excreted and enter the environment, contributing to selective pressure on microbial communities. This environmental aspect is often overshadowed by discussions focused solely on human and animal health. The implications are critical. environmental contamination can lead to the spread of resistant genes, creating a feedback loop that exacerbates AMR in both humans and animals. Understanding this connection underscores the importance of environmental monitoring and management in biosecurity regulations. 3. Economic implications for farmers. The increase in biosecurity regulations could impose economic burdens on farmers, particularly those in developing regions who may struggle to comply with stricter standards. This could lead to a disparity in the ability to manage AMR effectively between wealthier nations and those with fewer resources. The economic strain could result in reduced food production, impacting food security. Policymakers must consider these economic dimensions when formulating regulations, ensuring that support mechanisms are in place for farmers transitioning to compliant practices. 4. Consumer awareness and behavior. As regulations tighten, consumer expectations are likely to shift towards more responsible antimicrobial use in food production. This change may not be immediate, but raising awareness about AMR and its links to food production can lead to increased demand for sustainably produced foods. The significance of this shift is profound. Consumer behavior can drive agricultural practices and influence market trends. However, there must be a concerted effort to educate consumers about the complexities of AMR and the implications of their food choices. 5. One Health approach. The report advocates for a One Health approach, emphasizing the interconnectedness of human, animal, and environmental health. While this concept is gaining traction, its practical implementation often lacks depth in policy discussions. A holistic perspective that incorporates environmental health into AMR strategies is vital for developing effective interventions. The significance of this approach is that it encourages collaboration across sectors and disciplines, fostering comprehensive strategies that address AMR from multiple angles. 6. Regulatory frameworks and compliance. The regulatory frameworks proposed in the report, particularly in the EU context, are significant not just for compliance but for setting a precedent for global standards. Countries with stringent regulations may lead the way in establishing norms that influence international trade and practices. However, the bureaucratic complexities involved in compliance can be overwhelming, especially for smaller producers. Simplifying these processes while maintaining effectiveness is crucial for successful implementation. 7. Impact on research and innovation. The projected regulations may incentivize research and innovation within the healthcare, pharmaceutical, and agricultural sectors. However, the focus should not only be on developing new antimicrobials but also on alternative strategies to combat infections such as vaccines and probiotics. The significance here is twofold. Fostering innovation can lead to sustainable solutions to AMR while also addressing the pressing need for antibiotics that are less likely to contribute to resistance. 8. Monitoring and data collection. The need for enhanced monitoring and data collection regarding antimicrobial residues in AMR in the environment is a recurring theme in the report. Effective regulatory frameworks depend on robust data to inform policy decisions. The significance of this lies in the fact that without reliable data, efforts to combat AMR may be misguided or insufficiently targeted. Increased investment in monitoring technologies and methodologies could provide the necessary insights to guide regulatory actions. 9. Health systems preparedness. The anticipated increase in international biosecurity regulations will require healthcare systems to adapt rapidly. This preparedness is not just about compliance but involves public health education, improved diagnostic capabilities, and a focus on preventive measures. The significance of this readiness is critical. Healthcare systems must be equipped to handle the ramifications of AMR, including potential increases in resistant infections and the strains these could place on healthcare resources. 10. Legislative gaps and challenges. While the report outlines various regulatory measures, it also points to legislative gaps that could hinder the effective implementation of biosecurity regulations.
Addressing these gaps is significant because failure to do so could lead to inconsistent application of regulations and weaken efforts to combat AMR.
Policymakers must identify and address these gaps proactively to ensure a cohesive and effective regulatory environment.
Conclusion.
The projected 50% increase in international biosecurity regulations by mid-2025 represents a pivotal moment for the healthcare, pharmaceutical, and agricultural sectors. While many aspects of this development are widely discussed, the overlooked content identified here carries significant implications for global health, environmental sustainability, and food security. A comprehensive approach that integrates these considerations into the regulatory process will be essential to effectively combat AMR and protect public health. 1. Antimicrobial use and regulation. The projected increase in international biosecurity regulations will significantly impact antimicrobial use across healthcare, agriculture,
and pharmaceuticals.
The European Environment Agency (EA) highlighted a 28% decline in veterinary antimicrobial use in Europe from 2018 to 2022, with a goal of 50% reduction by 2030.
This decline is largely attributed to improved practices in biosecurity vaccinations and diagnostics.
The World Health Organization (WHO) has classified antimicrobial resistance (AMR) as a critical global health threat, pushing for stricter monitoring and regulation of antimicrobial use in both human and veterinary medicine. 2. Environmental impact of antimicrobials. The environmental consequences of antimicrobial usage are profound, as up to 90% of administered antimicrobials can be excreted and enter ecosystems, leading to increased AMR through selective pressure on microbial communities. There is a strong need for enhanced monitoring systems to assess the environmental impact of these substances, as well as to measure the effectiveness of regulations aimed at reducing their use. 3. Global trends and interconnectedness. The rising global demand for animal products is likely to increase pressure on farmers to use antimicrobials, potentially leading to a resurgence of AMR, particularly in regions outside of Europe where regulations may be less stringent. The interconnected nature of global food systems means that practices in one region can significantly influence AMR trends worldwide, emphasizing the necessity for international collaboration in regulation and monitoring. 4. One Health approach and policy implications. The concept of One Health, which recognizes the interconnected health of humans, animals, and the environment, is critical in addressing the challenges posed by antimicrobial use and AMR. A collaborative multisectoral approach is necessary for effective policy implementation that includes reducing antimicrobial use in food-producing animals, enhancing biosecurity measures, and promoting alternative farming practices. This approach will help mitigate risks associated with AMR and antibiotic pollution, ultimately contributing to public health safety and environmental sustainability. 1. The thalidomide tragedy, 1950s to 1960s. Thalidomide was a medication introduced in the late 1950s as a sedative and later used to treat morning sickness in pregnant women. However, it resulted in severe birth defects in thousands of newborns, leading to significant public outrage and a re-evaluation of drug safety regulations worldwide. This case highlighted the critical need for stringent drug approval processes and laid the groundwork for modern drug regulatory frameworks, emphasizing the importance of thorough testing and monitoring for safety and efficacy. 2. The Bhopal disaster, 1984. The Bhopal gas tragedy in India occurred when a pesticide plant leaked methyl isocyanate gas, resulting in thousands of deaths and long-term health complications for many residents. This incident prompted an international outcry regarding industrial safety and biosecurity regulations. The Bhopal disaster led to significant changes in safety protocols both in India and globally, including the establishment of stricter regulations surrounding hazardous materials and emergency preparedness, and it underscored the importance of corporate accountability in preventing environmental and public health crises. 3. The avian influenza outbreak, H5N1, 1997 present. The emergence of highly pathogenic avian influenza H5N1 in the late 1990s raised alarms about zoonotic diseases and their potential impact on human health. The outbreaks prompted governments and international organizations to enhance biosecurity measures in agriculture and poultry farming, leading to increased regulations surrounding animal health and food safety.
The H5N1 outbreaks catalyzed global initiatives focused on surveillance preparedness for pandemics,
and the need for cooperation between the healthcare and agricultural sectors to mitigate risks associated with infectious diseases. The projected 50% increase in international biosecurity regulations by mid-2025 is anticipated to bring transformative changes across the healthcare, pharmaceuticals, and agriculture sectors. This shift primarily centers on addressing antimicrobial use and resistance, AMR, a pressing global health challenge recognized by entities such as the World Health Organization (WHO) and the European Environment Agency (EA). Predictions and implications.
1. Enhanced regulatory frameworks.
By mid-2025, we can expect robust regulatory frameworks to be established at both national and international levels.
Countries will likely adopt stricter guidelines on antimicrobial usage in agriculture akin to the EU's recent initiatives.
This could lead to a harmonized approach to biosecurity, with countries cooperating more closely to implement similar standards, facilitating trade while ensuring public health safety.
2. Reduction in antimicrobial use.
Following the trajectory observed in Europe, where veterinary antimicrobial use has declined significantly, we can predict a similar trend globally. The integration of better biosecurity measures, vaccination programs, and improved diagnostic practices will likely lead to a marked reduction in the reliance on antimicrobials in food-producing animals. By 2025, a 30 to 50% reduction in antimicrobial consumption in agriculture, especially in developing nations, is plausible as awareness increases and regulations tighten.
3. Increased investment in alternatives.
The rise in regulations will stimulate investment in alternative health management strategies, including probiotics, bacteriophages, and improved animal husbandry practices. This shift may also promote research and development (R&D) in vaccines and diagnostics that reduce the need for antimicrobials, leading to innovation in the health sector. 4. Impact on healthcare systems. Healthcare systems will need to adapt to these changes, focusing on managing AMR more effectively.
Hospitals and clinics might implement stricter protocols for prescribing antimicrobials and increase their monitoring of AMR trends. By 2025, we could see the establishment of more comprehensive AMR surveillance systems integrated into public health strategies to track and respond to resistant infections. 5. Global collaborations. The interconnected nature of global food systems necessitates enhanced collaborations between countries. International organizations might play a crucial role in facilitating knowledge sharing, best practices, and compliance with new regulations. By mid-2025, we could witness the formation of global coalitions aimed at combating AMR, encouraging countries to share data and resources. 6. Consumer behavior changes. As awareness of AMR grows, consumer preferences may shift toward products labeled as antibiotic-free or raised without antibiotics. This trend could lead to increased demand for organic and sustainably produced animal products, prompting farmers to adapt their practices accordingly. By 2025, we may see significant market changes as consumers prioritize health and ethical considerations in their purchasing decisions. 7. Environmental monitoring and management. The environmental implications of antimicrobial residues in ecosystems will likely lead to enhanced monitoring and management practices. Countries may establish stricter controls on the discharge of agricultural runoff into water systems, aiming to reduce contamination and preserve biodiversity. By 2025, environmental agencies might implement comprehensive monitoring systems to assess the impact of agricultural practices on AMR. 8. Economic implications. While stricter regulations may impose initial costs on the agriculture and pharmaceutical industries, the long-term benefits of reducing AMR could outweigh these costs.
Improved public health outcomes and reduced healthcare expenditures associated with treating resistant infections may create economic advantages.
By 2025, countries that effectively manage AMR could see enhanced productivity and economic stability in their agricultural sectors. 9. Focus on One Health approach. The interdependence of human-animal and environmental health will encourage the adoption of a One Health approach integrating efforts across sectors to tackle AMR. By mid-2025, multi-sectoral collaborations will likely become more prominent, with joint initiatives involving healthcare, veterinary, and environmental professionals working together to mitigate risks associated with antimicrobial use. 10. Emergence of new technologies. The regulatory landscape may spur innovation in technologies aimed at monitoring and managing antimicrobial use and AMR. By 2025, we could see advancements in data analytics, artificial intelligence, and biotechnology used to track antimicrobial resistance patterns, improve diagnostics, and develop new treatment alternatives. Conclusion. The projected increase in international biosecurity regulations by mid-2025 is set to reshape the landscape of healthcare, pharmaceuticals, and agriculture significantly. As countries respond to the challenges posed by AMR, we anticipate a shift towards more sustainable practices, enhanced regulatory measures, and increased collaboration on a global scale. The implications of these changes will be profound, influencing not only public health and safety but also the economic viability of the agricultural sector and the protection of environmental ecosystems. The success of these initiatives will depend on continued cooperation and commitment from all stakeholders involved.